trigonometric equations, there are two types of solutions that we can get. There is the angle that exists on the unit circle. So this is any radian or degree measure that exists on that unit circle. For the purpose of your homework, you'll be solving in radian measures, but it is possible to solve for degree measure angles as well. The second type of solution that we can have is all solutions. When I say all solutions, I mean every possible angle that could ever potentially exist that solves this equation. So the way that we use these is we use our angle theta from the unit circle. Oh, goodness. And we add or subtract whatever the period is of our trigonometric function. So for sine and cosine, the period is 2 pi. So I would do whatever my angle is plus or minus 2 pi n, which indicates every multiple of 2 pi, either in a positive direction or in a negative direction. Tangent functions then have a period of pi, so we add or subtract every multiple of pi, which we use pi n to indicate. So if I ever say find all solutions, I mean find the ones that exist on your unit circle and add or subtract every multiple of that period. If I say find the angle between 0 and 2 pi, I only want the angle from the unit circle. It is possible to have more than one solution to an equation. Sometimes we can have 4, sometimes we can have 2, sometimes we can have 1, sometimes we can have none. So if you get more than one angle that fits the criteria, it's a solution. We're not limited by one angle here. Okay, so that is an important thing that you need to keep in mind. The easiest way to learn this is to jump right into an example, so that's what we're going to do. We are going to find both the angles from the unit circle and all solutions, just so you can see the difference in how the answers are written. Yes, ma'am. Well, cosecant and secant follow the same sign. Cotangent follows tangent because they contain the same period. But yes. What do you mean? Do you want to write them out, or?
No, if it's find all solutions for the 6 trig functions, do we have to write those also, or can you just do sign for that?
Well, it'll never say find all solutions for the 6 trig functions. It might give you a cosecant function and say find all solutions, and you would still just do plus or minus 2 pi n with your angles. You never have to write them all out. Okay, so the first example that I would like to do is a very easy one. It is sine of theta is equal to 1/2. So the reason that we are not using our calculator, even though we technically could, because this would just be an inverse sine function, is because calculators will only give us one answer, when in reality, there's typically more than one answer or more than one angle on the unit circle that works. Okay, it'll always give you the closest one to 0. So we don't want that. We don't want to be limited by finding just what the calculator tells us works. We want to find out for ourselves. So we're going to pull out our unit circle. We're going to go to the sine column on the back, and we're going to follow it all the way down until we find all the angles where our sine value is equal to positive 1/2. Those are going to be the solutions of this equation. So when you find one, raise your hand. Gabe, what'd you find? In radians, please.
Pi over 6.
Pi over 6. Awesome. Who else found pi over 6? Is that the only one that we found?
No.
No, Molly, what else did you find?
5 pi over 6.
Who else found 5 pi over 6? Are those the only two that we found?
Yeah.
Yes, they are the only two that have a sine value of positive 1/2. Do we all see how those two have a positive 1/2 sine value? Did we all see that on our chart? So these are examples. These are angles between 0 and 2 pi. What if I wanted to find all angles that make this equation true? What would I add to each of these?
Plus or minus 2 pi n.
Plus or minus 2 pi n. So that would be a satisfaction for every angle. If that's what I was asking for. You need to pay attention to the directions because it will tell you an angle from the unit circle or every angle. Colin.
Would we just add that thing?
Yes, this would be an answer for all angles.
Okay.
That's exactly how it could be written. Questions, concerns, or issues so far? Yes, ma'am.
If you added plus or minus to it and if it passed, would you kind of wrong?
Yes, because I need you to know the difference. Yes, I probably wouldn't take all points off clearly if you had the right angle, but you would get full credit. Okay, let's do another one. Oh, Molly, you have a question, honey?
Yeah.
Okay.
Do we just have to write that out, or do we have to solve it?
No, this is solving it.
Oh, okay.
Yeah,
No,
this
there's
is
a-
the solution.
Yeah.
Right, because it has an infinite number of coterminal angles, so. And that's all that is, it's finding every single angle that is coterminal to those given angles, because I know coterminal angles exist in the same spot, but with different angle measures. Next example. Tangent of u is equal to -1. On your unit circle, I would like for you to find the angle that makes this true or the angles that make this true, and then write the angles or write all solutions to this equation. It is a u, yes. It doesn't matter what variable we have there, whether it's theta or x or u or w or v or a, it still just represents an unknown angle. So I like to switch it up so we don't get confused if it's on like a test or a quiz or something like that. Find all the angles that make this equation true. Marissa, since you spoke, tell me the one or ones on the unit circle for which this equation is true.
3 pi. 7 pi.
Show of hands, who else got 3 pi over 4 and 7 pi over 4? I agree with that. Is that the answer I was looking for? No, because I said find all angles. So what are we missing from these two? Plus or minus pi n. Why is it pi n and not 2 pi n?
Because it's equal sign or cosine.
Because it's tangent, and tangent has a period of pi. How do we feel about that?
Tell me that's all.
Well, we're going to modify the equations a little bit, but this is all that we're doing.
Try.
And we only have 3 more examples.
Yo.
Yeah, super easy. Okay, next one.
This is what we make pages.
Goes from 0 to 100 in the next one.
These next 3 though.
I would just like to find the angles on the unit circle for which these are true. Or this one is true. So this one is actually a little bit different than what I've been dealing with in the past, right? What's different about it? Okay, it has a 2 multiple, but it's a 2 multiple on my angle, not on my whole trig function. This is only grouped with my angle. So that complicates things a little bit. There's a trick for getting around this. We're going to pretend to start with that 2 doesn't exist, and then we're going to factor it back in at the end. So instead of solving for 2 theta here, I'm just going to start by solving just for theta. And I'm going to find the angles on my unit circle for which this equation is true. When you have them, write them down. I want just the angles from the unit circle. And there are 2 of them. Jackie, did you find one?
Yeah.
What is it?
Pi over 2.
Did we find another one? Ismail.
3 pi over
3 pi over 2. Everyone find those. Yes. Okay. So this is where it gets a little bit different. I didn't just have a theta there. I had 2 times that theta. So to find the angle that makes it true, I actually need to divide that 2 out. So I'm going to multiply each of these by 1/2. And then that's going to tell me what my respective angles are. So if you want to think about it this way, we actually have 2 theta equals pi over 2, and then I have to get rid of the 2 by multiplying each side by 1/2.
Why are we trying to do that theta and not the cosine?
Because it's not in front of the cosine, it's in front of the theta. So now theta here is equal to pi over 4 as one of my angles. Yes.
Is this the same as dividing by 2?
Yes, same as dividing by 2 is multiplying by 1/2. Multiplying by 1/2 cancels out the 2 in the numerator, which is the same thing as dividing by 2. What we do to one, we also have to do to the other, so I need to do the same thing with my 3 pi over 2. So I have 2 theta equals 3 pi over 2. I'm solving just for theta, so I need to divide 2 from each side, same as multiplying by 1/2. And I get theta is equal to 3 pi over 4. So the 2 angles that are going to work for this one are pi over 4 and 3 pi over 4. So this only applies if I have a number multiplied by just the angle theta. We pretend it doesn't exist at first, and then we rework it with that multiple in there, and we have to divide it out. Does that kind of make sense? There are not a whole lot of these that I gave you on the homework. Are you ready for the next one? Maybe. Let's do it. We only have 2 left.
10-minute break.
No. It does feel like a Monday.
It's on data.
That was harsh.
I'm gonna go home.
Okay, so now I have the equation sine theta times tangent of theta equals sine of theta.
It heard of you are. You did say you were the reason it felt like Monday, so.
Dude, it's
You insulted me.
Okay, we're just gonna ignore all of that just happened. Okay, we're gonna focus here.
You're going to ignore.
We'll come back to it later. We'll come back to it later, honey. I
the school
promise.
system.
The school system.
Okay, Ismail. So now I have the equation sine theta tangent theta equals sine theta. What am I going to do with this one? Okay, so I kind of heard what we're gonna do. I think you have the right idea, but the wrong operations in your head. So she said that we're gonna subtract the sine theta over. When we subtract the sine theta over, it does not get rid of the sine theta I already have on the left-hand side. But that is the right move. We do wanna subtract that over because I want all my trig functions on one side of the equal sign. It makes it a whole lot easier to work with. So that's what we're gonna do first. We're gonna subtract that sine theta over. When I do, I'm left with sine theta tangent theta minus sine theta equals 0.
Why don't you just divide by sine
Oh.
and just get
Why
tangent
don't
theta
you
equals
just
1?
figure out that, like, in order for that to be true, that tangent has to be 1.
So what we're gonna do now is kind of what you guys just said, but we're gonna do it in a more algebraic way. So we actually don't want to divide sine out because sine is still a function that exists here and it does influence what's happening. But I do want to factor it out. So that's the whole purpose of moving everything to the same equal sign, is I can now factor a sign out of both of these terms. And when I do, I'm left with sine theta times, in parentheses, tangent theta minus 1, and then equals 0. So I just factored that sine theta out of both of those terms. And now what I can do, because I have the product of 2 terms, is I can take each of them individually, set them equal to 0, and solve. So now I have 2 problems. I have sine theta equals 0, and I have tangent theta minus 1 equals 0. Each of these will have their own set of solutions that I will then put together at the end for my overall solution for the problem. Start with the sine one because that's the easiest. Go to your unit circle. Where is my sine equal to 0 at? 0 and pi, but we can also say that 0 is 2 pi. So every multiple of pi is where my sine is going to equal 0, right? We can generalize that. So this is theta equal to pi n, because that's every multiple of pi, whether it's positive or negative, I'm going to have a sign value of 0. Oh. I just generalized, because you said it happens at 0, pi, and 2 pi, which means it happens at 3 pi, and 4 pi, and 5 pi, and 6 pi. So every multiple of pi is where my sign value equals 0. We generalized. You could have just left the 0 in pi, that's fine too. So now we're going to do the tangent theta minus 1 equals 0. What's the first thing I'm going to move here? Add the 1 to the other side. When I do, I get tangent theta equals 1. And I can use the chart on the back of my unit circle for this. What two angles have a tangent value of positive 1? Pi over 4 and 5 pi over 4. Quick question. What's the difference between pi over 4 and 5 pi over 4?
1.
1 pi. Right? So that means it's pi over 4 plus or minus any multiple of pi, which is equal to 1. So we generalize this one into pi over 4 plus or minus pi n as well. So those are my two solutions. If I wanted solutions for all angles that make it true, those green ones are the ones that I want. If I said angles on the unit circle, then 0, pi, pi over 4, and 5 pi over 4 would be your 4 solutions. Well, you could do that. So those are the alls, and then these would be the unit circle. Just depends on what I was asking for. And on your homework, I did ask for each. So you need to pay attention to what the directions are asking. Yes, ma'am. It'll say find an angle between 0 and 2 pi, or an angle from the unit circle, and it'll say find all angles if I want the green ones.
Okay, why is it plus pi and its sign?
Multiple of pi. Because you found out that the difference between 0 and pi is a multiple of pi, and then from pi to 2 pi was another multiple of pi. So instead of writing this as two different plus or minuses, I generalized to 1. That's all. You could have done 0 plus or minus 2 pi n and pi plus or minus 2 pi n. That would have been fine as well, if that's how you wanted to do it. We all kind of okay, Marissa? Yeah.
So sometimes they say
Some of them say what, honey?
NA, like there is no answer for that. What would you do? Will any of them?
Right, so some of them, there is no solution. You would just put no solution and move on. Yeah, sometimes it does happen. Ready for the last one? This one's my favorite.
Okay, well,
I got like 5 lines back.
It's gonna take more than 5 lines.
Oh.
Come on. It's all
2 sine squared t minus cosine t minus 1 equals 0.
No.
This is the last one though from the notes. Oh, I should probably move it down so people at home can see.
They don't need it. It doesn't matter. Not working. They don't matter. I don't see myself.
Okay, who has an idea of what we're gonna do first?
That's the one.
No.
Oh, never mind.
Yes, ma'am.
Try to take something out.
Well, it's very hard for me to take something out if they don't all contain the same thing, and none of them contain the same thing. So I can't do that either.
Move the 1 over.
Nope, that was already suggested. Quick question. Do all of my terms have the same trig function? No, my first one has a sine and my second one has a cosine. That's a huge issue. It's not an issue if they're being multiplied together, but because they're being added together, if possible, I need them to have the same trig function. So
Add the cosine over and then.
I am going to do a Pythagorean identity that's going to replace my sine squared with something in terms of cosine. Because I have a Pythagorean identity that has sine squared and cosine squared in it, so I know I can do that. What Pythagorean identity am I talking about?
Sine squared theta plus cosine squared theta equals 1.
What I'm trying to replace is sine squared theta, so I need to manipulate this identity to get sine squared by itself, which means I'm going to do what? Subtract the cosine over to the other side. Then I can take what sine squared is equal to, and I can replace sine squared with it. So then this becomes 2 times 1 minus cosine squared t, because that's what my theta is here, minus cosine of t minus 1 equals 0. And then I can move through it just like normal. First thing I need to do is distribute that 2 so I can combine like terms if possible. I can combine some like terms because I have a positive 2 and I have a negative 1, so I can put those two together. And then that becomes a plus 1. Are we all together so far? I'll pause here and let you catch up. While we're pausing, what is this equation starting to look like? A quadratic, which means that I'm going to be able to factor in a minute. We're going to make it look a little bit different to make it easier to work with, but we're going to be factoring here. First thing I want to do is make this first term positive. The only way to do that is to multiply or divide everything by negative 1. So I'm going to do that. If I wanted to start factoring this, what's the first thing I need to move? The 2 from the front. I need to rainbow that to my last term because I can't factor very well with a number on the front. It's also important to note that cosine squared t is the same as cosine of t all squared. So that's how I'm going to write it just for the ease of factoring. So I rainbowed and then rewrote the cosine squared t as cosine of t squared. Now, just like before, I'm looking for two numbers that multiply together to get a negative 2 and add together to get a positive 1 because that's a number in front of my cosine of t. Anybody have an idea of what two numbers are going to do that? 2, negative 1. Instead of having an x, I have cosine of t. So this factors into cosine of t plus 2 and cosine of t minus 1. That's a lot to wrap your brain around, so I need to make sure you understand how I did that. If it helps, we can think of the cosine t as just an x, because that's all it is. So this was the same as x squared plus x minus 2. Same concept. Since I rainbowed, what can I not forget to undo? The rainbow. So since I multiplied the 2 across, I also have to divide it out. This reduces to a positive 1, so I have cosine of t plus 1. This doesn't, so I kick the 2 over with the cosine of t. And now I have two factors that I can set individually equal to 0 and solve. I am only looking for angles on the unit circle for this problem. Bless you. So I have cosine of t plus 1 equals 0, and 2 cosine of t minus 1 equals 0. And I'm just going to solve each of them using my unit circle. So this first one is pretty easy. I just go ahead and subtract the 1 over. And then I use my unit circle to solve for t. Yes, ma'am.
Why don't we leave the last one?
I don't like to leave fractions and factors. You can. It typically doesn't hurt it at all. It just looks a lot nicer to read it like this.
So then what do you do?
Yeah, we're going to move it back across anyway.
Positive 1/2.
Yeah, it's going to move. It looks a lot nicer if I don't leave a fraction in the factor. That's all. Where is cosine equal to negative 1? pi. That's it. That's the only angle on my whole unit circle where cosine is equal to -1. So that's the only solution for that portion of my equation. Then I move on to the second portion. I'm going to go ahead and add the 1 over. I'm going to divide the 2 over, and I get cosine of t is equal to +1/2. And I'm going to use my unit circle again to find the angle or angles where cosine is equal to 1/2. I believe there are 2.
5/3 and 5/3.
Anybody else get pi over 3 and 5 pi over 3? Anybody get something different? Okay, this is my solution then, all 3 of these angles. Of course, you can write it out nicer if you want to. But then we are finished. How do we feel about all that? Your homework is 10 questions, but some of them are so extremely easy. Like I picked at least 3 of them that are just like the first one we did on here.
That's nice.
Okay. So homework is on Canvas, and we still have 20 minutes left. Yay!